Hey guys, this is Miss Weisler, and this is our next video lesson. So make sure you have paper and pencil or a pen so that you can take notes on this. It's an introduction to the power of quotients. We've had a quiz on the product rule and the quotient rule, and then the power of a power, and then power of a product. So this is power of quotients. So it's going to involve fractions. You'll have a few homework or a few assignment questions that you need to do afterwards, but mainly just doing the basics of this law. And we'll use more of this law as we learn the next two laws. Okay, the power of a quotient. When you raise a quotient to a power, multiply the exponent to all other factors in the quotient. So get your arrows popping backwards. Just like with the power laws with multiplication, if I have a 2 outside the parentheses, that means it needs to be distributed to everything that's on the inside. So in this case, the top and the bottom. So you end up with the answer of x squared over y squared. I just wanted to add to this, I forgot to mention that in this problem, x is to the first power and y is to the first power. Okay, I'm going to do a few of these with you. So you need to write these down in your notes as what we would normally say is we do. And then I'm going to give you some practice problems to do. And then your assignment, I still have to work on that. I'll tell you about that in a minute. So if you look at this first one, we have x over 4. It's inside the parentheses. So all I do is take the 2, and multiply it by the exponents that are on the x and the exponents that are on the 4. Well, since there were none, we know that x had an exponent of 1, and we know that 4 had an exponent of 1. So 2 times 1 is 2. 2 times 1 is 2. Now, I'm telling you that it's okay if you leave these as exponents. Okay? Just want you to see that technically it's x squared over 16. But right now we're just learning the laws, so if you can leave it like that, it'd be perfect with me. Okay, so this next example, I have x squared divided by 5, and see, notice the parentheses, the power of the parentheses. The parentheses separates what's going to have the exponent, or what the exponent is going to be applied to. So in this case, x has an exponent of 2. This 5 has an exponent of 1. You don't have to write it in, I'm just showing you. So you do 3 times 2, and then 3 times 1. So my x and my 5 now have new exponents. The x exponent, that's hard to say, is 6, and the 5 exponent is 3. As I'm writing 5. Oh my word, it's early. I wouldn't tell you how early. It's like 3:30. It's ridiculous. 3 times 1 is 3. So just to go over what I just did, I took the outside exponent, I multiplied it by the inside exponent with the x. The outside exponent, I multiplied it to the 1, which is with the 5. So it's 5 to the third power. Notice it's not 15. Okay? So this is your answer. You can leave it as an exponent. Obviously, if you had to simplify it all the way, then you would just do 5 times 5 times 5, which I know you all can do. And believe me, we'll do enough of that later. Okay, this next problem, I'm going to show you 2 different ways that you can do it. Okay, the first way is, you see how it's written 2a to the third over b to the fourth. Well, you can take that 5 and you can get your arrows popping backwards, and you multiply it by all exponents and factors on the inside. So that 2 has a 1 with it. Okay, so everything inside the parentheses, that 5 kind of owns it, if you want to think about it that way. So 5 needs to be multiplied by everything. Okay, so you end up with 2 to 5 times 1 is 5. 5 times 3 is 15. Over b to the fourth times 5 is b to the 20th. Yuck. It's kind of nasty, isn't it? But it is what it is, because remember, if you're simplifying anything, you want to get rid of the parentheses, and this is how you do it. Now, what I've done on this next one here is I just rewrote it, because if this entire division problem, which is a fraction, is raised to the 5th power, then I can break it down into 2 parts. I can break the numerator apart from the denominator, as long as I remember that I got to raise it to that 5th power. And this line is still here, the vinculum. Remember that word, vinculum? It's the line separating quantities. So, come on. If you just look at the top part, you have 2 to the 5th power, a to the 15th. And then if you look at the bottom part, you have b to the 20th. So sometimes you don't always have to do it this way. I'm just showing you that there's another way to do it. And it might come in handy on some of these when we have a lot of numbers in the numerator and denominator that need to be raised to the power of a quotient. Okay, so see how you get the same answer, although one is neater than the other. So either way, it's fine, okay? Whichever makes sense to you. Now I want you to take your pencil and your paper that you've been taking notes on. Hopefully you've taken notes on everything. And I want you to do these 3 problems. And they're very similar to the ones that we just did. So hit pause, copy the problems down, and work them out. And then come back and see how you did. Okay, for number 1, I'm going to change my pen color. I don't want to use white anymore. Okay, so what you have to do, come on, is take the outside exponent, multiply it by the exponents on the inside, which in this case they're both 1s. So my new problem is x, and 2 times 1 is 2, and then you get 5 on the bottom. 2 times 1 is 2. So that's it. That's the answer. Keep track of these if you get any of these wrong so that you can ask me about them later. We're going to have to be a little more structured with our lessons here. So this next one, x to the 4th power over 2. And then this entire thing is raised to the 3rd power. So I got to multiply the 3 times the 4. And this 2 here has an exponent of 1. So 3 times 1. So draw your vinculum. So that's x, and 2 is going to be in the bottom. So it's x to the 12th over 2 to the 3rd. So here again, on these 2, you could have worked them out if you had to. This would have been x squared over 25. Oh, beautiful handwriting. This would have been x to the 12th power over 8. Okay, I'm going to work out number 3 on the next page. Okay, on this last one, I showed you 2 ways you could do these. Actually, you could do this with all of them, but remember there's an exponent there of 1, so you're going to have to get your arrows popping backwards, to everything that's inside the parentheses. So that means every factor inside the quotient, if that makes any sense. Any number inside the parentheses, you have to multiply it by the outside exponent. If you don't see an exponent, then you know that exponent is 1. So this would be 2 to the 4th power over a, not over, beside a to the 40th, and then b to the 13th. That's the answer. Now, could you simplify this? Oh, yeah, I could do 2 times 2 times 2 times 2. I think what it would be 16a to the 40th over b to the 13th. But I'm not making you do that. Now I'm going to show you the other way that you could do this. You could take the 2a to the 10th, raise that to the 4th power, and then b to the 3rd, and raise that to the 4th power. And this might be an easier way when it gets real congested in here. So this equals 4 to the 1st power is 2 to the 4th. 4 times 10 is a to the 40th. 4 times 3 is b to the 12th. Why did I put 13th up here? Man, I am crazy this morning. What is wrong with me? I know, it's 3:30 in the morning. Okay. Okay, look at something like this. And I had put this on your practice problems for your assignment, but I'm going to restructure that because I was running out of room. So what you're going to do is I would probably break this up. You don't have to, but hurry to make enough careless mistakes. So now that I've broken it up, it doesn't matter if you did or not. You're still going to get the same answer. So I'm going to distribute that 3 to everything on the inside. So I get 2 to the 3rd, x to the 3, hold a pointer. 3 times 3 is 9. Come on. And then y to the 3rd. And then for the bottom, still using that 3, so that would be 3 to the 3rd power, z, that's a z, to the 3rd power. And that would be it. It looks very undone, and it is, because we're not taking that one extra step. If you wanted to, it would be 8x y to the 3rd over 27 z to the 3rd. So that simplifies it up a little bit, but this is okay. I just want to show you, if I took the 3 and multiplied it times the exponent that's with the 2, I would get 3 to the 3rd power. 3 times 3 is 9, x to the 9th power. 3 times 1 is 3, so that's y to the 3rd power. My vinculum, or division line, 3 times the 1 with the 3 goes 3 to the 3rd, and 3 times the 1 with the z is z to the 3rd. So breaking it up or leaving it all together is definitely just a preference. It depends on what you want to do. All right, then I'm going to give you some practice problems. We'll go over them soon, and then I'll show you the next 2 laws, and we'll be done and done. Have a good day, and peace out.